So here in section 12.3, we're actually going to find the regression equation, or the equation of this line of best fit or least squares line. So, and we're going to use the example of the Netflix data where we had subscribers on the X in millions versus revenue on the Y in billions. So let's go ahead and talk about how we find that first, and then we'll use the calculator to do the dirty work. So here's a simpler example. We've just got 5 data points, X versus Y. And then here's what the regression line looks like for that data. It's actually got the equation 10x plus 50. So how do we find that equation? Well, we have to define something called y hat, which is the estimated y value using the regression line. So for example, if we look at x equals 4, if we go up to the actual y value and across, or the actual point and across, we get this y value. Now, if we go up to the line, hit on the line, and go across, then that is our y hat value for that specific x. So there's a difference between the y and the y hat, and that's error that we get from using the regression line. And we call that error yi minus y hat, that error, the residual for y sub I. So I is which point you're looking at. So this is going to be y sub 4 and y hat sub 4. And then if you take the absolute value of that error, you'll get vertical distance, and distance is always positive, of the point xy from that regression line. So this is going to be your error, vertical error, which is absolute value of y minus y hat sub I. And so to get the regression line, what we want to do is we want to minimize the sum of square errors, is what SSE stands for. So the sum of all those errors squared over all possible points. So here we'd have 5 errors, square them, add them up, and we want to use the line that minimizes the squares, the sum of squares of those vertical errors. So using calculus, we can show that that line has the form a plus bx, where b is this expression, and a is y bar minus bx bar. So this is what calculus gives us. We won't derive that or use it. We'll actually use the calculator to do the dirty work for us. So the way that you do that, to find that least squares line using TI-84, is you input your x in list 1, your y in list 2, and then you go to stats, tests, LinReg t-test, select whether you want to test less than, greater than, or not equal, so negative slope, positive slope, or just slope not 0, and then calculate. So let's try that. So here in the calculator, I have already entered the lists in. So we're going to try this for the Netflix data. So x in list 1, y in list 2. We are going to go to stat, over to tests, and then LinReg t-test, I went up instead of down because it's quicker to get there. It's option F, and press enter. Make sure the X list is list 1, the Y list is list 2, and then our data here for Netflix, it pretty clearly goes up from left to right there. So I'm going to do a greater than 0 test here. So now I'll come down to calculate. And our regression line has the form y equal a plus bx, where our a right here, negative point approximately 97, and b approximately 0.13. And then there's some other data on the end there. So I copied that data from the calculator over here. And we'd like to know, what does that line look like on the scatter plot here? So you can get an idea on the calculator. So if you go to second stat plot, and make sure your first plot is turned on. So I'm going to press enter there, and off is highlighted. So I'm going to highlight on. Make sure the first graph type is selected. That's a scatter plot. Make sure your X list is list 1, Y list is list 2, and then this is what you want your point marks to look like. And then I'm going to press enter, and now I'm going to press graph. And there's our graph. So now if you don't see anything in the window, you might have to go to zoom and then press number 9, which is zoom stat, and then it'll line everything up so that it's inside the viewing window. So what's that line look like? Well, it's a plus bx, where a is negative 0.97 and b is 0.12. So negative 0.97 here plus 0.12x there. So if I go to y equal, I've already keyed that in, negative 0.97 plus 0.12x. I'll go ahead and turn that on. And now graph again. And there's our regression line on the scatter plot. So you can see it goes below these first 2 points and below the last 2 points, and then above the rest. So if we go back to our scatter plot, that's going to look something like this. So pretty close right there. So that's our line on the scatter plot. And then the only other thing that I'll mention here to wrap up is that your regression line, it cannot be used to make predictions outside the domain for the scatter plot. So if we go back up to our scatter plot here, that domain is starts here at a little higher than 25 and ends at, I believe it was 203. So you don't want to use your regression line to make predictions that are too much outside that domain of the scatter plot.